Hi, in this video I'll talk about RDD or the Resilient Distributed Dataset, which is the core component of Apache Spark. To do that, we will go through a very simple problem. I have a bunch of integers written in a file called int.txt. What we will do is sum up the odd and even and show the result. So to do that, this is our PySpark shell. PySpark comes with Apache Spark. It's a Python API, and the good thing is they have provided interpreter shells, so we can just type things around. Now, when we run PySpark shell, uh, Spark automatically comes with a thing called Spark context. For now, let's just remember that Spark context is a bridge between the application that we are going to write to the Apache cluster, Apache Spark cluster, right? Uh, Spark context has its own uh, very beautiful parts, but we'll come to that later. Okay. Now we have the file that I was talking about in a variable called in file, right? So we'll create our first RDD, which is called RDD1. We'll use the method called text file on Spark context, and we'll just say in file. Yep. So now Spark has understood that I want to read this file. At this moment, Spark haven't read anything. It hasn't loaded anything in memory. It just created a concept called RDD1 and pointed to the file, right? So this is what the RDD1 is. Now, uh, every object, every RDD in Spark comes with a very nice feature called the to debug string, which will show the lineage, and we'll talk about that later. Right, so RDD1 is dependent on this file called int.txt. Now, let us just see how many records are there in that RDD1. So now actually Spark is going and reading the file, and it uh, does so many steps uh, which are not of interest at this moment for us, but essentially it gives the result, which is 5 times 9, so we have about a million records. Now what just happened is we asked Spark to read the file and load it in memory. So what happens when Spark does that? So if I just try to write it in a visual format, it will look like this. So I have got this file, right? And when Spark reads it, it reads in something called partitions. So it creates a bunch of partitions depending on primarily the block size. Spark actually delegates it to various input formats. So if we have Hadoop input formats and pass it to Spark, Spark will gladly accept it and create partitions for each splits corresponding to the input format. But we have used text files, so it just goes by the block size, default block size, and created a bunch of partitions. And when we say count, it actually evaluated these partitions and read the files, created these partitions, and uh, gave us the count. So at this moment, the data is in partitions. The partitions can be in memory, can be in disk, but they're in partitions. Yep. So now let's do something. So remember, our objective is to create to actually calculate the sum of odd and even numbers. So for that, we need a function which will say that if the number is even or odd. So let's write it. It's going to be a Python function. So we'll just name it. We'll get some variable and we'll try to cast it to integer. Say b equal to int x. As we are doing it for fun, we are just saying that if there is we can't cast it to integer, I'll say it's 0. Right. Now, what we're going to do is we're going to see if it is a even or odd. So if we now what we are going to return is a tuple from Python, which will have because it's even. Well, I always mix them up and else. So now we have got this function. So what it's going to return is it's going to return is the value, the integer value, and a marker called even and odd, right? So how to use this? So for that, Spark gives a functionality called map. So let's create another RDD called RDD2, right? Now, this is a very, there's some couple of things going on here. First thing is when we created RDD1, it becomes immutable. So any RDD in Spark is you cannot change the values. It becomes immutable object. So whenever we do a transformation like this and we create a new RDD. So what happens if we go back to our visual picture, we had this thing called RDD1. Now we are running a bunch of uh, a transformation called map. So we get another RDD called RDD, right? And obviously, uh, each partition will get translated to one partition for RDD2. Now, this is a concept which is very important for Spark because everything is like based on partitions. So just to remember stuff, when we run something like transformation which depends only on one partition of the parent RDD, that is called a narrow transformation, and the dependency is called a narrow dependency. Going forward, we are going to write another kind of transformation which will need data from all the partitions or more than one partitions of the parent RDD. At that time, that will be called as the white transformations, and the dependencies will be called as white dependencies. So coming back to what we have. Now let's just to see what happened in RDD2. So how can we do that? Very simple. We'll say that let's take first 10 records of RDD2. So yep, Cool. So now we have this first 10 records, right? So we have got, okay, odd, 45 is odd, 41 is odd. Yep, 20 is even. Looks good. Now let's see what is the count. It should be same as RDD1. Awesome, it is same. It's saying it's 99999. So about a million. Now what we have is we had some integers. We have marked each of them as odd and even. Yep. Now what we are going to do is we are going to sum them up. So let's create another RDD called RDD3 and do RDD2 dot reduce by key, and let's write a lambda function which will take x and y, and it will give x plus y. Yeah, this is just addition function. So now RDD3 is created. Now going back to this picture, what happens when we run this RDD3 is it's going to run as a reduce function of a MapReduce program, right? So essentially it will create two buckets, two partitions, or maybe, and it will read data from all over the place. So now as you can see that RDD3, this has dependency on all the partitions of RDD2. This is called a white dependency. Now let's see what happens when we run this. So how can we do that? We'll do a slightly more fun stuff. We'll say RDD3 dot collect. That means it will return all the data to the driver memory actually, and we're going to print it. Right? So that's what we were looking at. That even this is the sum, odd this is the sum. So what we learned here is how to create an RDD, what is a RDD, and how a transformation like map works. That's called a transformation. Similarly, reduce by key is also a transformation, but the difference is map always work from partitions to partitions. That's why it's called a narrow uh, transformation. Reduce by key, it depends on multiple partitions of the parent. That's why it's called a wide dependency. Now, also what we have learned couple of actions like take and collect. Those are actions which force Spark to actually evaluate the RDD and show us the result. And if we inspect more, we'll see that return of take and collect in both cases are Python lists. That's why we could iterate it over. Cool. So that concludes this video. Thanks for watching.